Our next speaker will be Mr. Shravan. Yeah, he's a project lead at Construction 3D Printing Research Unit at the NUS. He graduated from Vellore Institute of Technology, India, with a bachelor degree in civil engineering. His research is purely focusing on iC3dP. He is a recipient of the American Society of Civil Engineers, which is a short form ASCE Student Leader Award, awarded by ASCE, and it's in Virginia, USA. An honor bestowed to only 3 students across the globe for possessing exceptional leadership qualities. He also led team in India's first concrete canoe team to compete in the ASCE Concrete Canoe Sportsmanship Award. The honor was covered by only 4 media organizations in India. He has won numerous other awards and scholarships, namely Special Achievers Award and U.S. Mathematical Olympic bronze medal, semester abroad scholarship, to name a few. He has also worked for Hong Kong Polytech University and worked on efficiency of sediment discharge curve using machine learning. During his time in Hong Kong, he also had a privilege working with another professor, very prestigious professor called Mr. Professor Skim Binni Shriki at the University of Hong Kong of Science and Technology on automation and construction. He was also invited to Huazhong University of Science and Technology, Wuhan, China, as a visiting researcher, and worked on optimization of iC3dP supply chain and assisted a government ongoing project on smart nozzle of their iC3dP gantry 3D printer. Let's welcome.
Thank you so much. Thank you so much. Well, so our research is mainly on development of 3D printing systems to accelerate the production of toilets in India. Before starting my presentation, I would like to invite our main project, the man behind this project, who's also known as father of 3D printed toilets of the world, actually. Please welcome Mr. Willie.
It's a very dubious title, but I will take it as a term of endearment and accept it. And before I begin, I want to thank NUS and anybody who's helped me from the beginning. To be quick, I started doing toilets 2.5 years ago, sort of as a doing my part to help the cause. And I'll be quick about it because we started using bricks, your regular cliche, the brick and mortar business. We were doing 1 toilet, 2 toilets a day. Slow, but it served my intents and purposes. Then after that, we moved on to precast panels. Again, labor intensive, but again, it served its purpose. So finally, last year, roughly April, I got really tired of the words disruptive technology. And I decided to say, hey, let's see if I can disrupt the construction industry and try to 3D print toilets. Because at the end of the day, if you look at the toilets, it's 4 by 4 by 6, non-structural. So in my mind, I said that's a perfect 3D printing project. Because again, it's non-structural, it's simple, and let's give it a try. I started off and I was introduced to Namik, Mahindra. They've been so successful and so helpful. And subsequently, I'm working with NUS on this. Now the challenge afterwards they will go through is the weight of the toilet. It's 1.2 tons. So my guys in India came back to me and said, hey, 1.2 ton ain't got to cut it because they're going to use bull carts and ship 1.2 tons of concrete. So they came back, and then this is the first time I came across the words DFMA, Design for Manufacturing and Assembly. My guys in India broke it down to components. And then the idea is now to 3D print the components and to be assembled. Again, you know, we packaged it such that it's like, our intention is to package it such that it's like IKEA. They just take it and go and they do the assembly themselves. So this brings us to where we are. And again, my deep appreciation to NAMIC and NUS for taking us to this stage. And with this, I will hand over to the guys at NUS.
So Mr. Shravan will be our next speaker, and he has a master degree in chemistry engineering, specialized in sustainable materials development for construction industries. So his journey of sustainability started when he launched computational model, which detects a 3D atmospheric dispersion of gases from any point source. The model was coupled with advanced equilibrium criterion model, which could assess the fate of emitted in different environmental media, developing cross-laminated timber and glued laminated timber was his next area. After performing the life cycle assessment, it was determined that total cost, energy, and GHG gases would be the timber building components made of local species are used in lieu of normal concrete. After a successful study, he kept the relationship with the sustainable construction alive by venturing into 3D printing technology. So let's welcome Professor Mr. Shreyan.
Thank you.
Oh, thank you. Before I start, I'd like to say, Maapa, I'm here. So, first up, our research is basically, we start off with our research, then Indian toilet system, the Indian toilet production problems, the suggestions on the toilet production, 3D printing toilet, what are the advantages and disadvantages of the 3D printed toilet, and after which we go into our future work. Well, what is open defecation? This is not happy to say this, but yes, one of the critical issues in India right now, wherein our Prime Minister Modi had played a huge role and is still playing and continuing to improve the sanitation facilities, the open defecation facilities in India. So, open defecation in India, well, India stands somewhere 13th on the list. The world, plenty of African nations before that. But why exactly India? Well, we went ahead because of simple aspect, the Indian population. India's population is somewhere around 1.3 billion people. So these statistics are from WHO and was about like 4 years ago, which states that 626 million Indians still open defecate. Something not to be proud of, but yes, I have to say this, and that's why we're researching on this. After that is Indonesia, which is just like 63 million odd people. So our government has spent over 30 billion US dollars and promised to build 90 million toilets, of which I must say not completed yet. Our research objectives are identification of toilet production problems, to list the suitable solutions for the toilet production problems, try and implement those solutions in real life situations. So we have taken like basically two field studies. One is right up in the north of India, which is like northeast, which is called Bihar, the province. And a second one is right down south, nearly 2,000 kilometers away in Tamil Nadu, India. Evolution of toilet, yes, the Indian toilet has evolved, but not with time. That's 2015, 2016, and 2017. And still not moving ahead, so yes, a huge problem again. So the typical Indian toilet system is this, a low-cost toilet introduced by the Indian government. It has 2 pits where you can see the waste materials go into one pit and the other pipe is blocked. After which, say 3 years or so, the pipe is opened and all the feces are collected and the other pipe is blocked after that. So we just wait for one pipe to be filled in, the other pipe is blocked. As you can see, that's the pit over here. Yes, the production process of the Indian toilet is basically the brick and mortar toilet. Indians are usually, and especially the villagers in India, they're usually not aware of precast or prefabricated, so they still stick with the brick and mortar toilet. As you can see, people start off making the soak pit, which is the collection tank of all the waste materials, and then they go on to make the base. After which, the soak pit is mounted on a level where the base is also flat, and then they build the body of the toilet and then the roofing in the end. So this is the typical production process of the Indian toilet. The production performance, this is the time, cost and quality analysis. I think many speakers have asked about this. So yes, this is the typical brick and mortar toilet, which costs about 21,750 Indian rupees, and roughly that comes up to 300 US dollars. And the labor required are like 4 people or so, which takes about 19 hours to build just one toilet. The business model in India is probably the most complicated one ever, because the money that goes to the individual households is not easy. The government just doesn't give the money so easily, so it has to go through a lot of process, which takes about like 6-7 months to reach the consumer's hand, which is a very tedious process. Even if we try to change it, the government has to change his mind first. Yes, so the individual household applies for funds, and then it goes to the government. Then the government sends in the funds. Then these are given to the contractors. And it goes in a huge cycle and takes in like 7-8 months just to receive the money eventually. So what are the Indian toilet production problems? Well, when we went to India, we just saw 3 major production problems, or in fact we put it into 3 different problems. One is the design problem, construction problem, and operations problem. Design problem, quite simple, we could see it. Construction problems were the ongoing toilet constructions, and operations, we had to ask the contractors how exactly the whole materials operations and the whole funds operations travel in India, which is a huge issue as well, because the contractors are not ready to give you the right amount. They sometimes hype it up. So yeah, the poor design features, as you can see over here. Just a second. No, previous one. Yes. So as you can see over here, this toilet is a typical brick and mortar toilet in India. Has poor design features, by means it has no ventilation at all, and has very little space, as you can see. So this is the next one, please. Okay. Next. Poor craftsmanship. Yes. So there's a laborer there who takes in just the water at any specific amount. There's no measurement given to him, or there's no measurement that he adds in. He just takes specific water and just throws the concrete over there. So that's again poor craftsmanship. As you can see, the finishing is quite bad. And it was surprising, because when I asked them how long does each toilet last, they said not more than 2 years. Slow construction process, where you can see there's one guy who's actually doing the finishing for it. He's doing finishing for it, but you can see it's not only him in the construction process involved. There are 5 others who are just watching him build the toilet. So overall there are 6 people building the toilet, but 5 people are ready to watch him, and the one guy is just printing the toilet. High construction wastage, indeed we're known for that, which is again quite disheartening, because there's a lot of construction wastage over there. Right there in the video you can see, all this was caught live on tape. So he goes in and they're just discussing on that, and right there 40% of bricks are being wasted right there for no use. Yes, high damage rate. An amazing shot. Yes, right there. That's the door. Can you replay it? Yes, please. Yes, right there, there's a door which is damaged. Oh yeah. I don't think it lasts even for 2 years now. Next. So other problems are simple, which are like the labor and the whole poor materials involved in it. I think materials, my colleague will know, give more explanation to it because he's researching on materials as well. The problems and the suggestions, the problems were simple, no windows, no ventilation, insufficient toilet space, inadequate lighting, no reinforcement, one of the critical factors for why the toilet lasts just for a couple of years. Heavy superstructure, no rainwater harvesting facilities, which we thought had to be there in a toilet, convert me. And we had given few suggestions to it, and what we thought, okay, fine, how can we make the whole process better? So how can the suggestions be incorporated? Well, we thought of just two things. One was a classical toilet, the other one was a modern toilet for the villages, classical for the villages in India, and the modern toilet being for all the major cities like Mumbai, Chennai, and Delhi, all these major cities in India. So we started off with our classical toilet. We have already printed it. If you guys had come to the lab for the opening ceremony, we had that. These toilets are already there, up and running. So our design of 3D printed toilet, it's purely based on real life situations. So what we did was we just thought, why can't we make a Lego block out of it? So we did it in multiple pieces. There are like the whole toilet is built 14 odd pieces or so that it's portable as well, and villages are ready to use it. So this is a production process of 3D printed toilet. As you can see, the printing is happening right there. The second photo shows in a reinforcement. A reinforcement meaning the laborers or the people, household people who are going to use the toilets eventually can carry it from one side to another. So India being highly labor intensive, so they are ready to carry that. And then the soak pit is being put, and all these parts that you see in the first one are being stacked together. And the fifth part is where we print the pits and the water tank. This is the production performance of a toilet. So the whole printing process, I'm not counting the calibration failures we had. Oh, we failed a lot. 6 odd months it took us to be on track, and we are still failing today. But the whole printing process of every component takes about just 4 hours, and the assembly takes about 1.1 hours in all, and all those facts are absolutely true. The cost of printing the toilet is 16,000 Indian rupees, which is again somewhere around 200 US dollars. So we've reduced the cost by 25%, and we've reduced the time by nearly 60 odd %. So advantages and disadvantages, obviously the advantages are no, I've hyped it up over here because it's my project. So the advantages are like high productivity and 29%, 0.86 cheaper than the brick and mortar one, reduction of construction wastage, as you can see over there. From the other news, yes, over to my other colleague Shravan, who would go on.
Thank you, Shreyans. My voice is clear there, right? Yeah. So for me, right, as a material department lead, this problem was not a big problem for me. Toilet as such is a non-structural unit. So for me, making a material which is 3D printable was not very challenging. But one fine day, I got a call from Jackie and Williams, told that I want the material to be lightweight. I want the material to be cheap. Those two words actually changed my day. That is when I went to India and did a background search and see like how can I make this material cheap and lightweight. So these are the exact clippings from newspaper. These are the headlines, which says that the problem was true in India. Then I went on site and saw that why there was a design failure in Indian constructed toilet. I mean, why toilets were like breaking in second day of construction and third day of construction. Then when I did a material point of view analysis, I found that these all were the criteria which they were not following properly. For example, water to cement ratio was not fixed. The cement, which is supposed to be a good, it is a binding agent, so it has to be stored in a really good storeroom. How cement binds it reacts with water and it hydrates, then it creates a binding link. So this should not be kept open. If it is kept open, it will be pre-hydrated, thus reducing the whole quality of the structure. But India, there were no designated storage room for the cement. So after going through this analysis, then I came to know that I have to change everything from the start. I can't use their tail, catch it, and do some material development. I have to start from first. That is when I wanted to use a new material. A new material which can make the whole toilet structure cheap and lightweight. How can you make any material cheap? You recycle the waste. So when we went to Bihar and when we went to Tamil Nadu, we found one thing really common. All eat rice. Everyone from India eat rice. But even though the culture changes drastically from north and south. So for me, that was the material I want to use, rice husk ash. So in the slide you can see that they're like huge, I'm not proud of it, but still, it's like huge tons of solid waste are generated, in which only 20% of waste are like regenerated. So he is the director of SBM. SBM is nothing but Swachh Bharat Mission. It is a program directly under Government of India, which takes care of the sanitation problem in India. He says that you create toilet, it's okay, but it has to be adopted by the people. That is when I came with the term called circular economy. Circular economy is, I want this toilet to be created by the person who is using it itself. I want the people, for example, villagers, collect waste from me, process it, and I use those waste to construct the toilet. And let them know that, oh, this toilet is constructed by you, so they will be more like adapted to the new system of toilet sanitation. Okay, so because of the time restriction, I'm just skipping a few slides. So rice husk, as I said, I chose rice husk because that was majorly produced in India and we can get it really cheap. And this rice husk can be used in 3 ways. Either use rice husk as it is in the material, or convert it into ash, or convert it into biochar. So difference between ash and biochar is, ash is open burning, biochar is, it has a controlled environment. That means the oxygen is not there, which is pyrolysis. So yeah, so this all technical terms. I did compressive strength analysis and found that when you replace this cement with 5% rice husk ash, 10% rice husk ash, there is an increase in compressive strength. Good for us. But there was a problem in rice husk biochar. In rice husk biochar, if you see, the equivalent increase in compressive strength is not as promising as rice husk ash. Same goes with splitting strength test, and same goes with fluxural strength too. So these are the 3 very elemental tests you have to do to say whether this material is good enough mechanically or not. Yeah. So durability test is apart from mechanical test. I had to do this because toilet construction anyhow has a huge area where the water will be seeping inside the blocks, right? So we have to see whether this whole toilet is durable enough or not. So with this durability study also, you can see when you replace cement with rice husk ash, the durability increases. Yeah. So okay, I'll skip. Okay. So this is a glance of Indian project. So we met the CEO of Jivika. Jivika is a government body who takes care of the water and sanitation facility in Bihar. And we met district magistrate, even the Tata Trust guy. Tata Trust is a big organization in India who takes care of all big construction processes. And we got a special invitation from Prime Minister of India also to present our work in front of the public. And that public were known as Swachhagrahi. Swachhagrahi in India means that people who fight for cleanliness. Yeah. Okay then. Thank you. Thanks a lot. That's it.